Hi class, I wanted to make one last video regarding the skills assessment. This was the last question that says find the exact value of the following or state that it is undefined. And if an answer is undefined, enter undefined. And the expression that they want us to quote find the exact value for is arcsine of sine of 7 pi over 6. Okay, so one thing that I feel like I always remember, this one used to confuse me because I used to be like, okay, arc sine and sine are going to cancel out. And we're left with 7 pi over 6. Yay! So it's just not hard at all. However, I mentioned before, I was very resistant to memorizing the unit circle. So I think this is all kind of part of that. So if you recall, there's a few more pieces of information that are helpful besides the fact that the arc sine and sine cancel each other out. Essentially, the biggest part is unlike when we're solving, like we did for number 20, okay, where we had to solve when like sine theta equals 0, and when cosine theta equals 1/2, and we had a bunch of these angles. Arc sine is very similar to solving a sine equation, but it's restricted. Okay, so it's not talking about all of the values of these trig functions. They're restricted. Okay, and I know there's a lot that's kind of into play with these trig identities and values and all this stuff. But another part of what I want you to memorize is the range of these trig functions. Okay, so the range of arcsine and the range of arctangent are both negative pi over 2 to pi over 2. Which you might be like, does that really matter? Unfortunately, yes, it does. It does matter. It's going to come back up. Both of these will come back into play later on. And then for arc cosine is the one that's a little different. It's from 0 to pi. Okay, so essentially, like if you picture the graphs of these, like these are going to just continue to stay in from negative pi over 2 to pi over 2 for arc sine, arc tangent. Arc cosine is between 0 and pi. If we didn't restrict them, they would not be functions. Okay, they would just be they would not be functions. They would fail the vertical line test. Okay, if you think about what the graph's going to look like. So that is another little piece of the pie that we have to keep in mind, okay, when we solve these, that I was not keeping in mind when I was just like crossing stuff off, because even just thinking about what I just wrote here, that the arc sine range is from negative pi over 2 to pi over 2, what that's saying is I don't want to get a value of 7 pi over 6. 7 pi over 6 is not between negative pi over 2 and pi over 2. It's just not. Okay, so there's some like a quicker way to do this one, and then there's a longer way. I'm just going to walk you through. I'm just going to go for it. Okay, so first things first, we'll just walk it all the way through, and then I'll show you how some people would maybe do this one a little faster, but I just want to make sure all of these pieces make sense. Okay, so first things first, let's start with sine of 7 pi over 6. Okay, so you might think, I don't know what that is, but no worries, you do know what that is, okay? Because you have finally, or you maybe already have, committed to memory that lovely first quadrant of the unit circle, that the sine of pi over 6 is 1/2. Okay, we have that down. And then the fact that it's 7 pi over 6, I know what quadrant that is. That is not the first quadrant. It's not the second quadrant because that would be 5 pi over 6. It's the third quadrant. Okay, it is over here in the third quadrant. It's 7 pi over 6, same reference angle of pi over 6. Okay, so same y coordinate value, it just happens to be negative. Okay, because the y values in the third quadrant are negative. So what I'm really being asked to find here is the arc sine of negative 1/2. Okay, so it's asking me what angle would give me a sine value of negative 1/2. Okay. And again, we're looking at one. Okay, one of them is in the third quadrant, but the third quadrant angles are not in the range of arcsine. It has to be between negative pi over 2 and pi over 2. So where else am I going to get like a y value of negative 1/2? Well, it's going to be in the fourth quadrant. right? It's got to be in the fourth quadrant. That's where I would get this y value of negative square root of 2. Like this point here would technically be square root of 3 of 2, negative 1/2. This angle, you could think of this angle, though, as two things. You could think of it as what we would usually refer to it as, which is like from 0 to 2 pi would be like double the denominator. 12 minus 1, okay? So that's 11 pi over 6. But again, it all comes back to that range of arcsine is from negative pi over 2 to pi over 2. So we're not going to say 11 pi over 6. We're going to think about this sort of as like reversing the unit circle backwards, okay? So it would be like negative pi over 6. All right, so that is how we're going to get the value of negative pi over 6. However, some people might have been able to figure out a little bit quicker. They do really essentially cancel out. Arcsine and sine do cancel out. However, we just have to make sure that that value has the same reference angle and it's in the right location. Okay, so 7 pi over 6 may be like, okay, that's pi over 6 and it's negative. How do I write pi over 6? As the reference angle so that it has to be a negative y value, but between negative pi over 2 and pi over 2. And you'd be like, oh, okay, that would just be like negative pi over 6. So you might not have to go through the whole shebang, but I mean, the shebang's not bad. If as long as, again, you have those key first quadrant values memorized, you'll be good to go. Okay, so thank you so much. I hope it's helpful. And if you need any more help, please let me know. Thank you.